All right, everyone. Today's math lesson is going to involve us taking a look at some material that we've talked about in the past, and then also taking a look at that same material and applying it to the present. So we have a triangle right here on the whiteboard that I've drawn for us. And on this triangle, I've given you no angle measurements, nothing. We don't know if this is equilateral, isosceles, scalene. We have no idea what the different angle measurements might be in there, so we can't make any judgments whatsoever about this triangle. What we can do right now, though, is name the different sides and angles of our triangle. Okay, so this angle up here, yeah, we could call it angle D, but remember, when we form an angle, we use line segments to make angles. So this up here is angle EDF, because I started at E, I went to the D at the middle point, and then down to the F. Okay, so notice how the angle letter is in the middle. Okay, over here, I have angle DFE. I started at D, went to F, and went to E. And then down here, I have angle DEF. Start at D, go to E, and over to F. Now, could this be angle FDE up here? Yes, it can. Okay, as long as that D is in the middle, I start at F, go to D, go to E, forms the same angle. So that's correct. This could be angle EFD over here. And then this could be angle FED. Oh, it spells Fed. What do you know? How nice. So we have those angles. We also have some sides here. Now, there are 3 sides in a triangle, so we're going to name those sides. And the sides of a triangle are made up of line segments. And remember, we use that little segment symbol. So we have segment DE here, and we have segment DF over here, and we have segment EF down here. So now that we've named up everything, we know that segments are named after the points that make up their ends. So E is over here, F is over here, so that's segment EF. This is DF, and this is DE over here. And similarly to how we named our angles, the line segments can be named in the reverse order as well. So this could be segment ED, this could be FD, and this could be FE. Okay, so that's naming our segments. What we want to take a look at right now is this next idea of the isosceles triangle. And remember, when we worked with isosceles triangles, we talked about 2 of the sides being congruent, okay, meaning that they're going to have equal lengths. So for example, let's make this an isosceles triangle right here. And we're going to call this side length over here 6. So if that side length is 6, in an isosceles triangle, we use these congruency tick marks. So if you see a line going through the triangle, somebody didn't make a mistake. They're actually telling you that they are congruent sides. These little tick marks mean congruency marks. So this side right here, where there's one congruency tick mark, is congruent to any other side of the triangle with the same number of tick marks. So this has 1 tick mark running through it. Therefore, these 2 sides are congruent. So this side over here is also 6. And I'm going to move that so it looks a little bit neater. Then down here, this side has no tick marks running through it. So this has a completely different measurement. And I'm going to call it, just for the sake of this argument, 3. So this is an isosceles triangle because it has one side that is 3 and then 2 sides that are congruent or equal in length. And they're going to have the same measurement. So that's 6. Now for this next little piece that I want to chat about, we're going to take a quick look at angles and how they can influence the length of a side. So what I'm going to do here is I'm going to use this rubber band and my 2 fingers as an angle. Okay? Now the angle right now is formed between my thumb and pointer finger. And we see that the angle is pretty small between them. And notice that the side length, the length of the rubber band between my 2 fingers, is relatively small. Now, what happens when I increase the angle? Okay, notice how I've made the angle now a little bit wider. Well now, because that angle is a little bit wider, the side length has become longer. And as I make that angle even wider, the side length becomes even longer still. So we can understand then that the bigger the angle, the bigger the side length. Okay? The bigger the angle, the bigger the side length. The smaller the angle, the smaller the side length. We see the rubber band becoming shorter and shorter and shorter as I move my fingers back together again. And as I move them further and further apart, the angle between my thumb and pointer becomes even wider. And once again, as I relax that angle, I make it smaller, that side length becomes shorter. So that's important to understanding here, that these two angles are going to be the same down here. Now, the way we can sometimes think about this is the congruency tick mark can kind of point to that opposite angle. So I'm going to grab this marker here, and I'm going to draw a little arrow on the tip of it over here, and it's pointing down to this angle over here. And this congruency tick mark is kind of pointing down to this angle. I'm going to erase that one because it wasn't so neat. We can also think about where these congruency marks are pointing, because sometimes the triangles are not so nicely drawn. We can also think about this. If the angle is on the congruent line, it's not the angle that's making that line. So this angle right here, if we think about it, this would be like the palm of my hand, this would be my pointer finger, and this would be my thumb over here. So this would be the side length, that's the rubber band over here, correct? This is my rubber band side. If I flip around, this would be like my thumb over here, this would be my pointer finger down here, and then this is the rubber band side over here that I'm tracing. Okay, so I didn't change the angle measurement, and I didn't change my side measurement. We're going to play around with that idea a little bit more. If we go back to our original triangle, and we take a look at the board again, we have triangle DEF still, and what we'll do is we'll say that side or segment DE, ooh, my marker's dying, get a new one. So side DE is congruent to side DF, or segment DF. This symbol right here, the equal sign with a little squiggle above it, means congruent, because congruent is the word that we use in geometry to mean equal. So these two sides are congruent. So I would draw a mark like this on that triangle. Now, we're going to take this a step further and be able to find missing angle measurements. And let's take a look at an example. If we were to say, this is our isosceles triangle. Well, let's call this, you know what, let's call this 65 degrees right now, just to have a little bit of fun with it. So this is 65 degrees right here. I know that this congruency mark is pointing to this angle right here, the 65-degree angle. This congruency mark is pointing to this angle over here. Well, if this side length, we don't care what the side length is. If this side length gives me a 65-degree angle, then this side length, again, we don't care what it is, has to give me a 65-degree angle as well. Now, I can ask you this question. I found angle DEF. I found angle DFE. Is it possible for me to be able to solve for angle EDF? Can I find this missing angle up here? The answer is yes. So in an isosceles triangle, the magic is I only have to give you one angle measurement, and you can figure out the other ones because there's congruent angles. So if you know one angle, you should be able to find another angle and then the third angle. So what I do is I'd add up what I have so far, correct? So this is what we've been practicing all along. 65 plus 65 is 130. And then if I do 180 minus 130, I'm left with 50 degrees up here. So angle EDF is worth or measures 50 degrees. Let's take a look at a few other problems now and see how we can use isosceles triangles to help us find other missing angle measurements. So in this next example that I've drawn out, I have an isosceles triangle, and it looks like it could be a right triangle over here, correct? It looks like this angle could be a right angle. Don't get tricked by that. We have to prove that this angle is a right angle or is not a right angle. So we can't just go by, it looks it, so it must be. That's not true in math. Math likes to trick us. So we know that side LM is congruent to side KL. So here's LM, here's KL. So we already have those congruency marks. Now the measure of KML is 48 degrees. Now the problem is asking us to find, can we find the measure of angle LKM? Well, I think I might be able to do that pretty easily. So this angle right here, we're going to take a quick little commercial break while I get a new marker. And, oh, much better. So we have that congruency mark seems to be pointing over here, but remember, that angle is not on this, this angle is on the line, this angle is on the line, so therefore this angle has to be the thumb and the forefinger, the pointer, and this is the rubber band, okay? So the 48-degree angle is controlling this rubber band. Over here, okay, this angle, this rubber band, okay? So this is also 48 degrees up top. Now we can prove that this is a right triangle or is not a right triangle. However, we've already answered one of the questions. One of the questions said, can you find the measure, sorry about this glare, the measure of angle LKM? We just did that. It's 48 degrees. We're done with that particular problem. Now we can work on angle KLM, this angle over here that we don't know. So we're going to have to add up what we have. We have 48. I'm going to do 48 times 2 because it's the same thing. And that's 96 degrees. So if I do 180 minus 96 degrees, I'm going to have 17 minus 9 is 8. So this is an 84-degree angle. Almost a right angle, but not quite. And we're done. We've solved for every angle in this triangle. And notice that we only started out with one congruent angle. Okay? In this next example, we're going to be finding the measure of angle x. And we have congruency tick marks again. So we're going to see where those are pointing to. So this is pointing down to the 65. So this over here is pointing to this over here, which must also be 65. That's why I'm able to fill it in. Congruent sides, congruent angles. Okay, that's the beauty of the isosceles triangle. Now I get to figure out what angle x is. So 65 times 2, 130, 180 degrees in a triangle, minus 130 degrees so far, gives me 50 degrees for angle x. So we have 50 degrees up top. All right, that's looking really good so far. Now, work with me on this one. Pause me if you need to at any point. I gave us some information up here, and we're going to have to make this problem make sense. So I'm going to try to put the glare where there's no information being blocked. So I have segment AB is congruent to segment BC. So I'm going to have to plug in my congruency tick marks. So segment AB, that's this one right here. I'm going to put a congruency tick mark on it. Segment BC, that's this one over here. I'm going to put a congruency tick mark on it. And the next piece of information is the measure of angle B is 110 degrees. So down here, angle B, 110 degrees. Now we need to find the sum of angle A and angle C. So altogether, what those are going to equal. All right, well, my arrows are pointing to the middle of line AC. That's not very helpful to me. So, excuse me, if I have segment BC, it's directly across from angle A. So this angle is congruent to this angle. And now we have the ultimate uh-oh moment, because we can find the measure of angle A and C together. If we do this problem, 180 minus 110, that gives me 70 degrees left in this triangle to play with. So that's what angle A and angle C together add up to. These two angles together add up to angle A and angle C. The very final step here says find the measure of angle A. How am I going to do that? I only know that there's 70 degrees between angle A and angle C. That's true, but I also know one other piece of information. This is an isosceles triangle, and angle A has to be congruent to angle C. So these have to be the same. These two angles have to be equal. So I have to figure out how to make 70 degrees divide equally into two angles. Sounds like I'm going to be doing division because I'm saying the word equal over here. So I'm going to do 70 divided by 2. So 2 goes into 7, that's 3 times. I have 10 ones left over, 5 ones times, and each of these angles are 35 degrees. So the measure of angle A is 35. Can I check that? Absolutely. I can do 110 plus 35 plus 35, and I can prove that this is a triangle that has 180 degrees in it. Okay, I'm going to get rid of some of this work over here so I have more room to do this final example with you. Over here, we have triangle XYZ, and we have some information. We just have to fill in some blanks up here. So we have some segment is congruent to some other segment. What two segments are congruent on this triangle? Let's take a look at where those congruency marks are. So I have segment XY has a congruency mark on it, and I have segment YZ has a congruency mark on it. So those are the two congruent segments. What angles are congruent? Well, let's put the little arrows on them, see if they point anywhere. This congruency mark seems to be pointing over here towards angle X, so I'm going to make a little arc over there. And then this congruency mark is pointing close enough to angle Z. I'm going to draw that little angle down there. So angle X and angle Z are congruent. Angle Y is the different angle in this isosceles triangle. So now what I have to do is take that measure of angle Y. Just like we did up here with angle B that was 110 degrees, now angle Y is 50 degrees. So I have to get rid of those 50 degrees to see how many degrees angle X and Z are going to share between them. So I'm going to do 180 minus 50, and I'm going to have 130 degrees left over. Now, when I have 130 degrees left over, we know that the next step is going to be divide, okay? And divide by the two remaining angles. So if I do 2 going into 130, I get that each of these angles are 65 degrees. So I have a 65 degree angle here, 65 here, 50 here. They add up to 180. So there's two kinds of isosceles triangles that you may have to work with. You may be given one of the two congruent angles, in which case you just have to realize you need to write the same angle measure on the congruent angle and solve for the missing angle. That's your different angle, okay? Over here in triangle XYZ, it's the exact same example as this problem, by the way. Over here, we gave you the different angle, okay? We had to subtract away the different angle and then divide by 2. If we take a look at my work, they're very similar procedures. They're just opposite in ways, okay? In this problem where I was given one of the two congruent angles, I multiplied by 2 and then subtracted from 180. Over here, I subtracted from 180, and then instead of multiplying by 2, I had to divide by 2 because I had the total number of degrees between the two angles. Now I needed to figure out what was their fair share, what was their equal portion, and that was 65 degrees. Today, what you're going to be working on is your math workbook, again, through the Google form. Everything is right here in the form, so you're going to have to answer a few vocabulary questions. Read over all of your answer choices extremely carefully. Look for your congruency tick marks and see if you can figure out what angle is directly across from those congruent marks. Over here, we weren't able to get the line symbol, the symbol for the line segment rather, above the XY or the XZ. So what you'll notice is that they're just capitalized letters that are together to show you that that's supposed to be a segment. Over here, the word angle was written out instead of using the angle symbol like I do on the whiteboard. So make sure you're reading all the questions really carefully. Check your math, your multiplication, addition, subtraction, and division very, very carefully. Double check to make sure that we're reading our angle names correctly in all of our problems, okay? So here I need RST, here I need TRS. So make sure you trace out those angles properly. And then read that final question over very carefully and see if you can do which of these are true. If you have any questions, of course, be sure to reach out.